Have you ever wondered where that tiny white sugar cube in your morning coffee actually comes from? It looks simple, but behind that familiar sweetness is an astonishingly complex chain of processes, from sun-scorched sugarcane fields to massive factories running around the clock day and night. Today, the global sugar industry is worth over $67 billion and consumes more than 16 million tons every year. About 80% of the world's sugar comes from sugarcane, which is primarily grown in tropical regions like Brazil, Thailand, India, and in the United States, Florida, Louisiana, and Texas. But here's an interesting fact. In the US, 60–65% of sugar actually comes from sugar beets, not sugarcane. Why? Because sugarcane needs a hot, humid tropical climate, while sugar beets thrive in temperate zones. In this video, however, we'll focus on the process of making sugar from sugarcane, the raw material behind the mellow sweetness you know so well. The sugar production process begins with selecting the right land for cultivation. The soil must drain well, have a reliable water source, and be rich in nutrients. Sugarcane is propagated mainly through cuttings taken from healthy stalk segments. From these segments, new shoots sprout and grow into mature plants. This entire cycle takes anywhere from 12 to 16 months, depending on the climate and soil conditions. When harvest time arrives, modern sugarcane harvesters take over nearly the entire operation, acting like agricultural beasts equipped with ultra-sharp rotating blades that slice through rows of towering cane stalks in seconds. Simultaneously, the machine cuts, gathers, and transfers the cane onto a trailer pulled behind, all in one continuous, seamless motion. Here's something not many people know. The sugarcane leaves once shredded by the harvester are returned to the field. This not only reduces agricultural waste, but also adds natural organic matter back into the soil, boosting fertility for future crops. The cane tops, which contain lower sugar content, are discarded. Only the thick, mature stalks where the highest concentration of sucrose is found are kept. These stalks are chopped into pieces roughly 12 inches long and sent down a conveyor belt into large holding bins ready to be transported to the mill. And if you think this is small scale, consider this. A single sugarcane harvester can process up to 11.5 acres, or about 500,000 square feet, in just one day. Once the bins are full, specialized trucks haul the sugarcane to the processing plant, where the real magic begins. When the trucks arrive at the mill, they unload the sugarcane onto the receiving platform, where not only cane stalks but also soil rocks and debris from the fields are present. From there, the cane moves onto a conveyor system and passes through high-pressure water jets. This initial wash removes most of the dirt, stones, dry leaves, and loose trash clinging to the stalks. After washing, the cane is roughly chopped and preliminarily crushed. The goal here is to soften the stalks and break down their outer structure like a warm-up before the real battle begins. Next, the cane enters a specialized crushing system. Massive steel rollers operate under immense pressure, squeezing the cane through multiple milling stations, typically 5 or more. As a result, every drop of sweet juice is thoroughly extracted from the fibrous material. The collected cane juice is channeled through a separate system for further processing. Meanwhile, the remaining dry pulp, known as bagasse, is separated and carried out of the line, ready to be reused as fuel or repurposed as a supplementary raw material. Now that the juice has been successfully extracted, it's time to begin processing it. But before that happens, a portion of the cane juice is sampled and sent to the mill's quality control lab. Their specialists conduct in-depth physicochemical analyses, the most important of which is measuring sugar concentration using a specialized polarimeter. Accurately determining the sugar content is crucial not only for evaluating the quality of the raw material, but also for adjusting the production process, forecasting yield, pricing the incoming sugarcane, and ensuring compliance with technical standards. After testing, the juice moves into the primary treatment system. At this stage, it passes through a coarse screening system to remove any remaining fibrous residue. Next, the juice is heated to approximately 221 to 105 to break down enzyme structures, eliminate microorganisms, and accelerate the settling of impurities. The juice is then directed into a tall tower, where it undergoes a sulfur gassing process known as sulfitation. As sulfur dioxide gas rises and comes into contact with the cane juice, a chemical reaction occurs that helps prevent bacterial growth and restores the juice's pH balance. After undergoing sulfitation, the cane juice continues through further treatment to remove dissolved impurities and stabilize its pH before entering the concentration stage. To achieve this, a dilute slaked lime solution is prepared by mixing powdered lime with clean water, creating a mildly alkaline mixture. This milk of lime is gradually pumped into the flowing cane juice. At the same time, the entire mixture is directed into a continuous mixing tank where it is stirred consistently for 5 to 6 hours. This step, known as alkalization, adjusts the pH to a stable range approximately 7.2 to 7.5. One noticeable change during this process is the color of the juice gradually shifting from dark brown to light yellow, indicating that many organic impurities are precipitating out. The resulting mixture is transferred into large static settling tanks. Here, the juice remains still for several hours, allowing the precipitated solids to sink to the bottom. In the concentration area, the purified cane juice is processed through multi-effect industrial evaporators. The primary goal here is to remove most of the water content in order to raise the sugar concentration to a level suitable for crystallization. To preserve sugar quality and avoid unwanted color changes, the entire system operates under vacuum conditions. By lowering the pressure, the boiling point is reduced, allowing water to evaporate without caramelizing the sugar or producing an undesirable brown hue. After several stages of continuous evaporation, about 66% of the original water is removed, increasing the sugar concentration in the syrup to 60–70%, an ideal level for the next step, crystallization. Next comes the crystallization phase, a key stage in forming raw sugar crystals. This process takes place in a special vacuum pan, where both temperature and pressure are precisely controlled to create an ideal environment for crystal formation without altering the sugar's color or structure. Once the syrup reaches a saturated state, tiny seed crystals known as crystal starters are introduced to trigger and accelerate the growth of new sugar crystals. Under slow agitation and gradually decreasing temperature, a crystal network begins to form throughout the syrup. The resulting thick mixture, known as massicute, resembles a dense sugar mud with countless crystals suspended in uncrystallized syrup. From there, the mixture is pumped into high-speed centrifuges. These machines spin at speeds up to 1/200 RPM using centrifugal force to separate the molasses from the sugar crystals. The molasses is flung out through small perforations in the drum wall, while the remaining sucrose crystals stay inside. To improve purity, a small amount of water is sprayed over the spinning crystals to rinse away any remaining molasses. The result is raw sugar with a purity level of 97 to 99%, ready for the final stage, drying. In the final step, the moist sugar crystals are fed into a hot air drying chamber where they tumble continuously in a stream of dry air until their moisture content drops to just 0.2%, the ideal level for storage and packaging as common table sugar. Once the drying process is complete, the raw, dry, and sparkling white sugar is collected and poured into large bulk bags, each weighing approximately 200 pounds. These bags are neatly arranged on loading platforms ready for transport to the packaging area. An automated crane system can lift up to 3 bags at once, speeding up the process while ensuring safety. Next, each bag is fed into a central receiving hopper, which channels the sugar down to the main packaging zone. Here, workers open the bags and conduct a quick visual inspection before the sugar is directed into the automated filling system. Depending on market demand, the sugar is packaged in a wide variety of formats, from 1 to 2 kilo plastic bags for household use to large bulk sacks for the food industry. restaurants, hotels, and coffee shops are also served with convenient mini sugar packets filled and sealed at speeds of up to 2,500 packets per minute, thanks to a modern high-precision packaging line. Once packaging is complete, the finished products are automatically sorted and organized, then wrapped in protective plastic film. Finally, these clean white sugar products carrying the pure sweetness of sugarcane are carefully prepared for distribution to supermarkets, factories, and dining tables all around the world. And just like that, our journey through the sugar production process has taken us from lush green cane fields to the pure white sugar crystals, a product born of hard work, advanced technology, and human ingenuity. We hope you not only enjoyed the experience, but also gained a deeper appreciation for how that familiar sweetness in every meal is truly made. If you're still curious and eager to explore more wonders of manufacturing, stay with us for our next video, where we'll uncover the fascinating process behind luxury perfume production. You'll witness the magical transformation from raw ingredients to each exquisite drop of fragrance. The link to that video is posted in the first comment below. Don't miss it. If you found this video helpful, be sure to like it and share it with your friends to spread the love of discovery. And don't forget to subscribe to the channel so you won't miss any of our upcoming adventures. See you next time.